Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. In this video, I want to discuss about set associative mapping. Okay. Now, in the previous videos, we have discussed about the direct mapping and associative mapping. Now, what is the drawback of the direct mapping? Even let's take that there are some cache lines are there, okay, and you have number of lines are 4. Let's take that. Now block number 0 of the main memory will also come in the cache line 0. Let's take that this is cache line number 0, line number 1, line number 2, line number 3 is there. And main memory has 32 blocks. Main memory, let's take that it is having 16 blocks just for make it simplicity. Then what will happen? Block number 0, block number 4, block number 8, block number 16 can place it in line number 0. Am I right or wrong? Of the cache memory. Similarly, block number 1, block number 5, block number 9 and block number 13 can be placed in the line number 1. And similarly, block number 2, block number 6, block number 10 and block number 14 can be placed in line number 2, and the block number 3, 7, 11 and 15 can be placed in the line number 3. Am I right? Now let's take that if I have the references as block number 0, block number 4, block number 3, block number 7, block number 11 from the main memory. Let's take that these are the access are required from the cache, the CPU, and it is trying to fetch it. Now what will happen? CPU is asking for a word which is there in the block number 0. Then what will happen? First time it will be a miss because it is not there in the cache memory. Cache is empty right now. Then what we will do? We will have to place it in the cache memory and CPU will execute it. Now I need to find the block number 4. Block number 4 is not there in the cache memory. Again it is a miss. Let me represent as cross miss. Okay. So block number 4, if you see that I can place here or I can place here or I can place, because these are 3 empty if it is not a direct mapping. However, as it is a direct mapping, block number 4 has to place it in the line number 0. So I have to remove this one and keep it here. Are you able to understand? And another thing is that let's take that block number 3 is there. Block number 3 is there where I should keep? I should keep it in the line number 3 because there is a fixed positions are there in the direct mapping. Okay, again it was a miss. And block number 7. Now if you see that block number 7 where I have to keep? In the line number 3. So I have to replace it with the block number 3. So this is the drawback. Are you able to understand? Some lines are empty in the cache. However, we are replacing the existing one. So this is one of the drawback of the direct mapping. And when it comes to the associative mapping, what is the drawback? The drawback of the associative mapping is the searching, because block number 0, block number 4, any block of the main memory can be kept in any one of the line in the cache memory. Meaning is that there is no fixed location. Whereas in direct mapping, block number 0 should be kept in the line number 0. That restriction is not there. It can kept it anywhere. So the drawback of the direct mapping is the block replacements one. And another one is that it comes to the associative mapping, searching is the problem. Are you able to understand? Here the block replacement is the problem and here the searching is the problem. But what is the advantage of each one? In the direct mapping, the advantage is that you will have the in direct mapping the advantage is that you have a fixed location. Block number 0 should be kept in line number 0. So searching will be easy in the direct mapping. And in the associative mapping, the advantage is that what is the advantage of associative mapping? The block replacement will be better because we are not wasting the line numbers. Even if it is all the lines in the cache memory is filled, then only we will think about the replacement. Otherwise we will not think about the replacement. So there is an advantage with the direct mapping and there is an advantage with the associative mapping. So what they have done, they have combined the advantages of direct mapping and associative mapping and designed a mapping technique called set associative mapping. Now we will discuss how it will work. Okay, why it is called as a set associative. Now let's take that. Usually they will call it as a k-way set associative or two-way set associative. We are talking it as a set associative. Let's take that they are written it as a two-way set associative. Okay. Now what is meant by two-way set associative or associative mapping is that it can be a 2 or it can be a 4 or it can be 8, anything. Now what will happen? The main memory is divided into blocks. As we already discussed that main memory consists of so many words and each block can consist of words. So main memory will be divided into blocks. Until now we have discussed that the cache memory is divided into lines. Line number 0, line number 1, line number 2, line number 3. The number of lines will be depend on the cache memory size and the block size. Okay. Now what we will do in the set associative mapping is that all these lines we will divide into some sets. Okay, let's take that it is a two-way set associative. Then what I will do is that as the number of lines are 4, and as it is a two-way set associative, I will divide by 2. Then how many sets you will get? You will get 2 sets. So this will act as a set number 0, this will act as a set number 1. Because you are dividing into 2 sets. Are you able to understand it or not? It is a set-way associative mapping. So if it is a two-way set associative, I will divide all the cache line into 2 sets. Then how the main memory block will be placed in a set number, that we will discuss. Let's take that I have a block number 0, block number 1, block number 2, block number 3, block number 4, so on. Some 8 blocks are there. Okay, block number 7, 6, 7 is there. Now where these blocks will be fit in which set? Okay. Now how we will do is that the block number 0. Okay. So block number 0 in which set I have to fix it is 0 modulus number of sets. How many sets are there here? 2 sets. Whereas in direct mapping, what we have done? The 0th block modulus number of lines. Whereas in set to associative mapping, how many sets it was there? 0 modulus the number of sets. So the block number of the main memory modulus the number of sets in the cache memory. If you see that we have 0 modulus 2, you will get the value as 0. So in set number 0, it has to place. Now in set number 0, you have 2 lines. Line number 0 and line number 1 are there in the set number 0. Then what you will do? You can keep anywhere. You can keep here or you can keep here. So if you see that this is the way a direct mapping will work. Whereas in direct mapping, you will have the number of lines in the denominator. Here you have the number of sets. So this concept we will call it's similar to direct mapping. Now in associative mapping, it can be kept in anywhere. So inside the set, the number of lines, n number of lines are there, the block can be kept in anywhere. So this concept is similar to associative mapping. So that's why I called it as a set associative mapping is called as a combination of direct mapping and associative mapping. Okay, are you able to understand? So let's take that I have kept the block number 0 here. Now let's take that block number 4 came. Let's take that I need to keep the block number 4. Block number 4 where I have to keep. So 4 modulus. The number of the block is 4 modulus the number of sets. The number of sets are 2. So you will get the remainder as 0. Are you able to understand? You will get the output as 0. Now already inside the set 0 you need to keep. Inside the set 0 you already have a block number 0 in line number. So you will keep here. You no need to replace the block number 0. Okay. You can keep here because it is free. Now let's take that. Let's take that I need to keep the block number 6. Where I should keep 6 modulus 2. The remainder is 0. If I get a remainder 0, the meaning is that I have to keep it in the set number 0. Already set number 0 is filled. Block number 0 is there in the line number 0. Block number 4 is there in the line number 1. Then what you will do is that you will use a replacement technique. Either LRU or FIFO or any replacement technique. Based on the replacement technique, you will replace either, you will remove the block number 0 or block number 4 and keep the block number 6. Are you able to understand? Let's take that I have a block number 7. Just for make you understanding, I am discussing so many examples. Block number 7 is there where I should keep 7 modulus 2, which is remainder is 1. So you need to keep it in the set number 1. Set number 1, you have line number 2, line number 3. Anywhere you can keep it. Okay. So this is where the set associative mapping will work. Now let me discuss about how the physical address is divided in the set associative mapping, or how it is classified. Now, as you know that the physical address basically consists of block offset and block number. Okay. So you will have a block offset, and here you will have in set associative mapping, you will have the set number. Whereas in direct mapping, you have the line number here. Here in the set associative mapping, you will have the set number. And the remaining bits are the tag bits. Okay. Now we will discuss each one. Now the total size of the physical address, or the total address space of the physical address, depends on the number of words are available in the main memory. Are you able to understand? If the number of words are 32k words, okay, 32k words are there, then it will be 2 power 5 and 2 power 10 to 15 is the 15 bits are required for representing the physical address. Okay. Now, I hope you have understood how I calculated the total number of bits is, or I can say that physical address bits, meaning is the tag bits plus set number bits plus block offset number will be 15. Just for an example I am telling. Okay. Now how the block offset we can calculate? The block's offset will depend on the size of the block. Okay. Let's take that the size of the block is some 128 bytes are there, or 128 words are there. Is it clear? Then you can represent 128 words or 128 bytes in 2 power 7. So then the block offset will be 7 bits. Okay. Now set number will be depend on how many sets are there. Okay. If you see that in our example, 2 sets are there. If 2 sets are there, 2 sets can be recognized using a 1 bit. Are you able to understand? 2 sets can be written as 2 power 1. So take the 1 bit. Okay. So then the remaining bits will be the tag bits. Let's take this in this example, tag bits will be 8. Just for your understanding, I am discussing. Are you able to understand? So the set associative mapping is classified into 3 parts. One is the block offset, depends on the size of the block, and the set number depends on how many sets are there in the cache memory, and tag will be the remaining bits. And now you can ask how many tag bits each cache bit. So let me write here. Each cache will have a tag. Am I right or wrong? Each cache line will have a tag bits. Now, where this tag bits will be useful for you is that the set number will tell the block resides in which set. Now, inside the set, if you have n number of lines are there, in our example 2 lines are there, the block can be placed in any one of the line. Am I right or wrong? So, this tag bits will be useful where it is actually, whether it is there, or if it is there, where it is there. Now, let's discuss with one example. Okay. Let me write it as a 5-bit, 6-bit address or 5-bit address. Let me write it as 6-bit address. Okay. Let's take the tag bits are 2 bits are there, and set number is 2 bits are there, and then this is 0, 1 is there. Let's take that. Then what is this word? word number 011101 I am searching. What is this value? This is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. So nothing but 16 plus 8 plus 4 plus, okay, 16 plus 4 plus 16 plus 8 plus 4 plus 1, which is equal to 24, 28, 29. So I am searching for a word number 29. So the word consists of 6 bits. So I have kept it in a 6-bit address. Now if as it is a set associative mapping, you will have a block offset. Let's take that block offset is having 2 bits. Okay. Similarly, set number is 2 bits and tag bits also 2 bits. So you have a block offset, you have the set number, and you have a tag bits. Then if you have a 2 bits for the set number, then how many sets are there? The meaning is that you have 4 sets. Am I right or wrong? You have a 4 sets are there. Set number 0, set number 1, set number 2. Set number 0 is there. Set number 1, set number 2, set number 3 is there. Are you able to follow it or not? Let me erase this one. You have set number 1, set number 2, set number 3 is there. Because you have allocated 2 bits for the set number. Then using the 2 bits combination, you can generate 4 sets. So that's why set number 0, set number 1, set number 2, set number 3. So then how we will search the particular this word is existing in the cache memory or not? If it is there, then we will say that it is a cache hit. Otherwise, we will say that it is a cache miss. Then what I will do, as this word is having the set number 11, 11 is nothing but 3. Am I right? So you have to go to the particular set number 3. Are you able to understand? Then you have 0, 1. Let's take that in this set you have 2 lines are there. Okay, in this set you have 2 lines. If you have 2 lines, you have 2 tag bits, not tag bits, you will have 2 tags. Are you able to understand? Let's take that in this particular set, okay, you have 2 lines are there. The meaning is that you have totally 8 lines in the cache memory, because if it is having 2, this is having 2, this is having 2, this is having 2, you will have 8 cache lines are there, and you have divided into 4 sets. Okay, then the set number 3 will have 2 cache line bits are there. That is nothing but L6 and L7 are the line numbers are there in this set number 3. Then whatever the word you are searching, or whatever the block, because inside the block the word will be there. If you identify the block, if it is there, then the particular word will be there. Now let's take that whatever the block you are searching, you have to match with the tag bits. If it is tag bit is 0, 1, okay, then you can say that in this line, whatever the word you are searching will be there. How you will search? Inside the 2 bits are allocated for the block offset. Then meaning is that block size is 4 words. Am I right or wrong? In a block, if you have 4 words, then only you will allocate the block offset as 2 bits. Then 4 blocks are there. If it is 0, 0, then you are searching for this word inside the block. If it is 0, 1, then you are searching for the first block. If this is, I am considering it as a first word in the block, then this is 0th block or 0th word. Are you able to understand it or not? Let me, not to make you confused, let's take that in the block number 1. Okay, in block number 1, you have word number 4, word number 5, word number 6, word number 7 are there. Let's take that. Then this 0, 1 meaning is that this is the block, because this one will have a index 0, 0. Are you able to understand? Meaning is that this index here it is 0, so you will represent as 0, 0. This index here it is 1, so that's why you will have the binary number 0, 1. Okay, and this index will be 2, you will have the binary representation 1, 0. In this block, the word index 7 is having 3, so you will have the number 1, 1. So you are searching for the second word. So you will go to the particular block and you will identify the second word. Okay, so this is the way the set associative mapping will work. I hope you have understood the basics of set associative mapping. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will clear your doubts in less than 24 hours. Thank you for watching my video. Have a nice day.